destroying the Earth is harder than you may have been led to believe. For example, look at this pebble. Could you destroy this pebble? Not with your hands, probably not by stepping on it. Maybe if you had tools, for example. This pebble would be pretty hard to destroy. Now imagine trying to destroy a pebble 1 million, billion, trillion times bigger. Luckily, though there's no such thing as the Death Star, there are a couple of dozen ways we can destroy the Earth.
Here's one of them. This pebble is made of antimatter. Alright, I know what it looks like. Just play along. Antimatter is the mirror image of ordinary matter. If this anti-pebble and this pebble met, they'd annihilate each other completely, leaving nothing but energy. As much energy, in fact, as a 1 megaton nuclear bomb. Antimatter, you see, is the most explosive substance possible. So here's your method. Take a mountain-sized chunk of antimatter, drop it on Earth from space. Or, if you want to be more efficient about it, carve a hole to the Earth's core and drop the antimatter down the hole, blowing the planet up from the inside. The result? A second asteroid belt around the Sun. Very simple. The problems are twofold. Firstly, antimatter explodes if it touches anything made from ordinary matter. This anti-pebble would explode if it touched the sofa I'm sitting on, or the glass bottle that it's inside, or even make contact with ordinary air, because all of these things, like everything in the known universe, are made from regular matter. The only way we can store antimatter is in a special device called a penning trap. Penning trap has a vacuum inside, which means there's no air for the anti-pebble to touch, and it also has special electromagnetic fields which keep the pebble inside without ever touching the sides of the bottle. Unfortunately, penning traps are very difficult to make, and just trapping a few atoms of antimatter for a fraction of a second is the best we can do with current technology.
The second problem is, right now, antimatter could only be manufactured very slowly in particle accelerators. To make a real anti-pebble, like the fake one I'm holding here, would take 100 billion years. The mountain-sized chunks we're looking at would take ridiculous amounts of time, effort, and most importantly, money. Make no mistake, this would work. But, while the state of the art is improving, the technology we need is way beyond us right now, and is likely to remain that way forever. Feasibility rating? I think 5 out of 10.